Yeah, check everyone. Audio video is okay or not? Yeah, check everyone. Audio video is okay or not? Yeah, let me start now. Before going to start the actual class, let me say something about Unacademy. So those people who are right preparing for the competitive exams, if you are a computer science person, or you want to write the computer science, you want to get the computer science jobs. I am repeating once again. If you are belongs to computer science, or you want to work in the computer science industry, if you are seriously preparing for computer science jobs, maybe software jobs, maybe GATE exam, maybe PSU exams, anything of CSE, if you want to join, my sincere suggestion is download Unacademy learning app. This is my suggestion. Download Unacademy learning app. Afterwards, scan this QR code. Right? You will get approximately 100 free classes. Not 1 to 100 free classes which are having top quality. If you are a computer science student and you are preparing for competitive exams of computer science, that may be GATE exam, that may be PSU exam, that may be software companies, you may be preparing for placements, right? So after downloading Unacademy learning app from the Play Store, scan this QR code, you are able to find out so many quality videos which are free, right? So please utilize this, scan this QR code. Next one, see everyone now, right? Algorithm subject is going on, followed by DS. Algorithm subject is going on, followed by DS. Algorithm subject going on, followed by DS. Tomorrow recursion will start. Actually, in my opinion, actual algorithm DS is started tomorrow class. Tomorrow morning this class, right? Tomorrow morning 7 a.m. to 10 a.m. class is there. Algorithm data structure class tomorrow 7 a.m. to 10 a.m. Algorithm class tomorrow 7 a.m. to 10 a.m. Recursion going to start, right? If you want, you can join in that batch, right? So use the referral code ReddySir. So for computer science students, I am teaching algorithm. Data structures, programming, TOC, compiler design, computer network, discrete mathematics. For CSE people, I am teaching algorithm, data structure, programming, TOC, compiler design, computer network and discrete mathematics. Tomorrow morning 7 a.m. to 10 a.m. algorithm, data structure, recursion going to start. In my opinion, this is the algorithm first class. Right? Please don't miss it out. Next one, you can join if you want to access my classes. If you want to join, you can go for a plus course also, you can go for iconic also. Next one, those people who want to join in Unacademy, 20% off is available. You can utilize it. On every subscription, whatever students will take, 20% off is available. Right? This offer is valid, right? July 29 only. Until July 29, this offer is valid. Use the referral code ReddySir. Price hike is going to be very soon. My suggestion is, right? Please escape this price hike. Means you join before only, so that you will get some advantage. If you are serious, my suggestion is please join as soon as possible. Right, fine. I'm thinking you are really comfortable. Let's go to the today's first problem. This is the first problem. Can you check? This is the today's first problem. Let's see what answer you can give. Construct minimal DFA that accept all strings of A's and B's, where in every string number of A's divisible by 2 or number of B's divisible by 3. R operator, R operator, R operator. Number of A's divisible by 2 or number of B's divisible by 4. Number of A's divisible by 2 or number of B's divisible by 4. Try. What will be the answer? Number of A's divisible by 2 or number of B's divisible by 4. Let's see what answer you are going to give. It's a very tricky problem. Let's check. It is R operator. Let's see how many people will give answer. Let's see. Number of A's divisible by 2 and number of B's or number of B's divisible by 4. It is a R operator. It is a R operator. Remember, it is a R operator. But interesting thing is, listen, everyone who is watching this class, for everyone I want to say to you, this one. Number of A's divisible by 2. R operator. Remember, it is R operator. And next one, number of B's divisible by 4. Remember, right? So on A's condition is divisible by 2, on B's condition is divisible by 4. Remember, R operator, AND operator doesn't matter because of different symbol. You cannot minimize anything. Answer is 2 into 4, 8 states. You cannot minimize because condition on the different symbol. You have to multiply blindly. If at all condition on the same person, you can minimize something. Because of condition on different people, you cannot do anything. Please, this is a very important. It is a very important problem. Whether it is R operator, AND operator, doesn't matter. Condition on different people multiply. Right? Divisible by 2. Number of A's divisible by 2 states. Number of B's divisible by 4 states. R operator, right? What is the answer? Right? Because of it is a different symbol, simply multiply. If anyone having any doubt, let me know. If anyone having any doubt, let me know. If anyone having any doubt, let me know. So can you see the next problem also? Similar, see this one, similar. Number of A's divisible by 2 or number of B's divisible by 5. See this one. Number of A's divisible by 2 states. Number of B's divisible by 5 states. Simply product automata, 10 states. Because different symbols. Because of different symbols. Please check. Anyone having any doubt? Construct minimal DFA that accept all strings of A's and B's, where in every string number of A's divisible by 2 states, number of B's divisible by 5 states. Because of a different symbol, simply multiply. Because of different symbols, simply multiply. Yes, perfect. Let's go to next problem. Can you see this? I am expecting answer. What answer you are going to give? It is a AND operator. Can you check? It is a AND operator. It It is a end operator. So what is the answer? End operator. End operator. See this one. End operator. It doesn't matter. End or R. It doesn't matter. End or R. A's number of A is divisible by 2 states. Number of B is divisible by 4 states. End or R doesn't matter. 8 states. You cannot do any minimization. Because of different symbol, you cannot do any minimization. So careful. Careful. See the next problem. Can you check this? Can you check this? Every possible combination I covered. Every possible combination I covered. Every possible combination I covered. Otherwise people may confuse. That is the reason. Every possible combination I just kept one problem. So what is the answer? Number of A is divisible by 2 is 2 states. Number of B is divisible by 5 is 5 states. End operator, R operator doesn't matter. 10 states. 10 states. Right. Yeah. Can you see this? Can you see this problem? What will be the answer? Whatever you are thinking, you write. Whatever you are thinking, you write first. Within few minutes, I will explain. I am giving 2 minutes time to you. I am giving 2 minutes time. Whatever you are thinking, you try first. Let M be the encoding of Turing machine as a string over 0, 1. Let L is equal to M, where M is a Turing machine that accepts string of length 2014. Then L is. Please write your answer in the options. Please write your answer in the options. Please write your answer in the options. M is a, see this one, remember language L is equal to set of all Turing machine that accept a string of length 2014. Then L is. So remember M is a Turing machine that accept a string length of 2014. So string length 2014 it will accept. If you give string length of 2014, right, it will say yes. It will say yes. Means what is the meaning of yes? Halt final. If you give string length of 2014, right, answer is yes means halt final. If you give other than 2014, then what happened? It means if you give no strings, if you give no 2014, right, other than 2014, if you give, right, it may say no, it may go to halt non-final. So I am repeating once again. If you give string of length 2014, right, then this is the story. If you give 2014 less than that, 2014 more than that, means if you give invalid strings, what happened is, right, it may say no by going to halt non-final, or it may halt, or it may go to hanging also. It may hang also. If you give invalid strings, it may go to halt non-final and it will say no, or it may hang also. Hanging is possible. For valid thing, listen, valid thing also hanging is possible. Valid thing also hanging possible, then it is going to be completely undecidable. But valid thing no hang. Valid thing it will go to halt final. Invalid thing there is a hanging possible. Invalid thing if you give no will be answer, or hanging is possible. So valid thing no hanging, invalid thing hanging possible. So indication that undecidable but recursive enumerable, because valid things, see this one, for everything no hanging, that is called recursive. At least for valid thing no hanging, that is going to be recursive enumerable. Suppose assume that valid thing itself hanging possible, then it is going to be undecidable and not REL also. But here valid thing no hanging. See, 2014 string, if you give valid thing, yes, alt final. If you give other than 2014, it may say no, or it may go to hang also. No also possible, hang also possible if you give invalid. Right, that is the reason it is undecidable but recursive enumerable. B is the answer. Suppose assume that for valid also no hanging, invalid also no hanging, that is called decidable, which is called recursive, right? Yes also, valid also no hanging, invalid also no hanging, that is called decidable. Valid also hanging possible, invalid also hanging possible, valid also hanging possible, that is going to be undecidable and right, non-recursive enumerable. Please careful, right? At least valid things hanging not there, that means REL. I am repeating once again, at least valid things hanging not there, that is called REL, but it is undecidable. Suppose that valid also hanging possible, valid also hanging, undecidable and not REL. Right, fine. So answer is B. For every valid thing halting final, invalid thing may hang also, because of hanging is there, undecidable, that is fine, but at least for valid no hanging. So that means recursive enumerable, Decidable recursive enumerable. What is the meaning? Decidable recursive enumerable means valid also no hanging, invalid also no hanging, that is called decidable recursive enumerable. It is a really nice problem, please take care. Can you see this? What is the answer of this problem? Similar, can you check this? Yeah, let me read it. Which of the following languages are recursive enumerable languages? Which of the following languages are recursive enumerable languages? 1. L is equal to M, where M is a TM and there exists an input whose length is less than 100. Right? L is equal to M, where M is a Turing machine and there exists an input whose length is less than 100, on which M halts. M is a Turing machine and there exists an input whose length is less than 100, on which M halts. So I think by seeing this one you can easily say that, right, there exists an input whose length is less than 100. So what happened is, you will try only 100 length strings only. You will try until 100 length strings only. 100 length strings are only finite. 100 length strings are only finite, but when you are trying those, few may go to, few may not halt also. There exists a input whose length is less than 100, where M is halts. So what you do is, you will check one by one string, right? Less than or equal to 100 is only finite length strings only, but one by one you have to verify. While verifying, right, some may go to halt, right? At least one person will go to halt final, then stop it. If you are lucky, starting itself can go. If you are lucky, starting itself it can go. If you are unlucky, starting maybe go to hang. Next one may go hang, but at least one person you will find out. You no need to check all the people. 100 or less than 100 length you check, right? If you are lucky, starting itself, right, you will go to, right, halt final. If you are unlucky, right, worst case, maybe until 100 length you have to verify. But anyhow, this is undecidable but recursive enumerable. Undecidable but recursive enumerable. Let's see the remaining options also. L is equal to M, where M is a Turing machine. L of M is equal to 0, 0, 1, 1. L of M is equal to 0, 0, 1, 1. Right? This is what the answer? Right? M is a Turing machine and L of M is equal to 0, 0, 1, 1. So remember 0, 0, 1, 1 only it should accept. 0, 0, 1, 1 only it should accept. So but you have to verify all the people, because it should accept only these two. You have to verify all the people, because other people cannot accept. Suppose that not only 0, 0, 1, 1, it is accepting some more also, it is going to be invalid. So you have to verify every person. So that is the reason it is undecidable. And one more is going to be recursive enumerable. No, it is a completely undecidable, because you have to verify every person to know valid or not, to know this is right or wrong. Everyone you have to verify, because suppose that if you don't verify, 000 also may satisfy. If you check 00 satisfying, if you check 11 is satisfying, no, other people should reject also. So you have to verify every person you have to verify. So it's undecidable. And right, there is no chance of recursive enumerable. And one more, there are 3 Turing machines, M1, M2, M3. Language of M1 is equal to language of M2 union language of M3. So there is no algorithm. There is no algorithm to verify 2 Turing machines are equal, 2 Turing machine languages are equal or not. Equality Turing machine fail. So it is also undecidable. This is undecidable. This is the undecidable, right? But REL. Undecidable but REL. Please careful. Answer is going to be which one of the following is recursive enumerable? 1 is the answer. 1 is the answer. 1 is the answer. Second one saying that Turing machine should accept. Second one is saying that Turing machine should accept only 0011. Suppose that 00 you tried, yes, accepted. one you tried, it is also accepted. It doesn't mean that you will stop. It doesn't mean that you will stop. You have to check every person. You have to check every person, not one person, two person. You have to check every person. So to get right valid, to verify the valid thing, everyone you have to verify. To verify the valid one, everyone you have to verify. Not only these, not only 0, 0, 1, 1. You have to verify every person. Because 000 may satisfy. If 000 satisfied, this is wrong. 000 satisfied, this is wrong. Because, right? So to say this language is correct, 0, 0, 1, 1 should satisfy, right? Remaining all should reject. You have to verify everyone. Are you rejecting or not? Are you rejecting or not? Everyone you have to ask, right? Which will goes to everyone you are verifying, which will goes to, right, undecidable, but not REL. Right? That is the answer for this. Answer is 1. Answer is 1. Let's check this. Can you help me? What is the answer of this? Take your own time, try to give answer. Take your own time, try to give answer for this. Which of the following is a non-regular language? L is equal to Wx Wy, where Wxy belongs to a plus b whole plus. L is equal to Wx Wy, where xy belongs to, right, xy w belongs to a plus b whole plus. Next one, L is equal to xw yw, where xy w belongs to a plus b whole plus. L is equal to Wx yw, where Wxy belongs to a plus b whole plus. So I think if you observe clearly, I given a lot of time, this can be written as, listen, this can be written as starting with a, w can start with a also, right? A followed by a plus b whole plus. a followed by a plus b whole plus, next one a followed by a plus b whole plus. So remember whatever w if you give, in the w starting symbol e will give, in this w starting symbol e will give, remaining things, right, x will eat, remaining things here y will eat. Similarly, right, starting with b also, in the first w, right, starting is b, remaining x will eat. Second w starting is b, remaining y will eat, remaining y will eat, right, please be careful. So regular expression possible, it is regular, regular expression is possible, it is regular. So see the second one, almost similar. If you see the second one, right, a plus b whole plus, right, in the w, first w, last letter is a, before that all x will manage. In the similar way, a plus b whole plus, right, in the second w, right, last symbol is a. So last symbols, right, you can manage, you can write. So remaining before whatever there, here x will eat, here y will eat, r, one more thing, r, right. So a plus b whole plus followed by b, a plus b whole plus followed by b. This is the regular expression for this. Please check if you want. So it is also regular. Next one, L is equal to Wx Yw. Here problem will come. Because see this one. Because first symbol of W, right? Remaining all X will take. Last symbol of W, remaining all Y will take. What is the meaning? I think you are targeting first symbol of W, last symbol of W. There is no linking. There is no relation. See, first symbol, there is a relation. See this one. First symbol of first W, first symbol of second W, same. Next one. Last symbol of first W, last symbol of last W, same. But one thing, first symbol of first W, last symbol of the last W, no relation. Unnecessarily don't keep any relation. So what is the answer? 3 is wrong. Which one of the following is non-regular? 3 is non-regular. 3 is non-regular. Right. Let's go to next problem. Can you verify? What will be the answer for this? Can you verify? Verify what is the answer. Which of the following language is regular? Yeah, let's see the answer. I hope you people tried. Which one of the following is regular, they are asking. Which one of the following is regular, they are asking. Let me try once. Which one of the following is regular? I think if you observe clearly, this one, if you observe clearly, right, wx w power r, wx w power r, where x w belongs to 0 plus 1 whole plus. This means if this w starting with 0, this w power r should ends with 0. Everyone know, it is a palindrome. Remaining all 0 plus 1 whole plus. R, if w starting with 1, this w power r should be ends with 1, in between anything. Check. So this x is, right, helping, x is helping, take care. X helping, take care. Starting with 0, ending with 0, or starting with 1, ending with 1. So this is regular. But if you see the remaining, x is there, either x is there extreme corner, either here or here, no use. Here no x at all. W power r, it is a even length palindrome. No x to help. Here x not there, so no way. Here x there, extreme right side. After work is over, x is there. So we cannot help. Right, next one. X w power r, extreme, x is there, extreme left. It is also no use. Small change also serious problems will come. Careful. Small change also serious problems will come. Please verify. Answer for this problem is, right, I think 3. Now can you try this? The minimum state automation equivalent to the above finite automata has the following number of states. I think if you observe clearly, see this one, if you observe clearly, this is the DFA okay, but he is asking minimal DFA how many states. He is asking minimal DFA how many states. I think you can apply minimization algorithm, you may get the clarity. But one thing, if you want to apply minimization algorithm, you have to remove the dead state. I think it is the dead state. See this one. No one can reach it. From starting state, no one can reach it. From starting state, no one can reach it. I think you can delete. No one can reach this one. So total remaining, if you observe, 3 states are there. But right, can I minimize anything? Let's check. Can you help me now? I think if you observe clearly, starting with A, I think if you observe clearly, A followed by anything, I think it looks like A followed by anything will work out. A followed by anything will work out. I think if you want, you can see this one. Starting A, you will come to Q1. On Q1, A also accepting, followed by any number of A's accepting. Next one, only B is also accepting any number of times. Any number of times A is also, any number of times B is also accepting. If you want, you can check whether you are at here, accepted. So A, you come to here. Afterwards anything it will accept. I think in my opinion, the purpose of this problem is containing A as substring. I'm thinking this problem is containing A as a substring. Let's see. Q0, Q1 containing A as substring. Before A, anything can come. After A, anything. Over. I think this is the answer for this. It is a starting state, it is a final state. Containing A as substring. If you want, you can check. In that automata, only B is rejected here also. B is followed by A accepted. A followed by anything accepted. I think this automata, if you observe, containing A as substring, which required exactly 2 states. Answer is 2. If you want, you can apply minimization algorithm. If you apply minimization algorithm, you will get. See, before going to apply minimization algorithm, please remove dead states. The state from which, right, I cannot reach final state. The state from which I cannot. Sorry for this one. What is the meaning of dead state? Sorry, it is not dead state, to be frank. It is not a dead state. Unreachable state. Sorry for that. It is not a dead state. It is an unreachable state. From starting state, I cannot reach Q3. From Q0, I cannot reach Q3 at all. Unreachable state. Eliminate unreachable states first. If you want to apply minimization algorithm, first step, eliminate unreachable states. Afterwards, apply minimization algorithm. Eliminate unreachable states. Afterwards, apply minimization algorithm. Answer is 2. Yeah. Can you see this? What is the answer of this problem? A minimum state deterministic finite automation accepting the language L is equal to, right, something, number of zeros and number of ones in W are divisible by 3 and 5 respectively. See, number of zeros divisible by 3 and number of ones divisible by 5. I think, see, different symbols, different condition. Zeros divisible by 3, 3 states, ones divisible by 5 states. 3 into 5 blindly because of different symbol. 15. Answer is 15 states always. Answer is 15 states always. Answer is 15 states always. If it is R operator, see this one, AND operator 15, R operator also 15. R operator also 15, AND operator also 15 because different symbols. We are already done this. It is one of the previous paper question. It is one of the previous paper question. Please be careful. Yeah, can you say what is the answer of this? What is the answer of this? Can you verify? Consider the following languages. L1 is equal to something like that is a Turing machine that visits state Q on some input within 15 states. 15 steps. Consider the following languages. L1, right? So M is a Turing machine that visits a state Q on some input. That visit a state Q on some input within 15 steps. That visits a state Q on some input within 15 steps. So he is saying within 15 steps. So after 15 steps you can stop. Right? He is saying that visit a state Q on some input within 15 steps. Within 15 steps. After 15 steps you can stop and you can say. Next one. So L2 is a some language M where M is a Turing machine. Size of M is less than 200 where M is a number of states. Yeah, so I think the answer is this one. See everyone now, every input on some input is saying, so you take the input, every input do only 15 steps. That visit state Q on some input within 15 steps. So just take the input, 15 steps you do, right? Are you there in the state Q or not, verify. If not, take the next one. There is no chance of a hanging. So it is a decidable. It is also decidable because, right, M is, right, number of states in the automata is less than 200. Number of states are always finite, right? So I think answer is going to be both L1 and L2 both are decidable. Verify once. If anything wrong, let me know. If anything wrong, let me know. If anything wrong, let me know. Both L1 and L2 is decidable. Yes. Yes. The size, the number of states in the automata is less than 200. Just verify how many states are there. There is no chance of hanging, because whenever Turing machine is given, number of states also given. Please check how many states are there. There is no chance of hanging. So every string, listen, every string, just to do 15 steps. After 15 steps are over, please verify is it state Q or not. If it is Q, stop. Otherwise, take the next string. Right? Do 15 steps. Q or not, verify. No, go next. Everywhere 15 you will stop. There is no chance of hanging. So L1 is decidable, L2 also decidable because of number of states. Because of L2, right? Because of number of states. Answer is both. It's a really nice problem. It is a really nice problem. It is a really nice problem. Right, let's go to next. Can you try this also? What is NPC, NPH? Please explain. Ashish, it is not there in the GATE syllabus as of now. As of now, it is not there in the GATE syllabus. Otherwise, I could have explained. Otherwise, just Google it out, you will get it. If you really need it, just Google it out, you will get it. Otherwise, you can see in the YouTube. You can see in the YouTube, you will find out so many videos. Which of the following are undecidable? 1. Given two Turing machines M1 and M2, decide if L of M1 is equal to L of M2. Everyone know, right? Equality of Turing machine is undecidable. Next one, given a Turing machine M, decide if L of M is regular. Turing machine language is also accepted by regular, no one knows, undecidable. Given a Turing machine M, decide if M accepts all string. Totality of a Turing machine, undecidable. Given a Turing machine M, decide if M takes more than 1073 steps on every string. Given a Turing machine M, decide if M takes more than 1073 steps on every string. Just to do, listen, just to do every string 1073 steps you do. Afterwards, stop. Right? Every string do 1073. Is asking, decide if M takes more than 1073 steps on every string. So just check here, until here it came. If it is stop, it's okay. Otherwise, do one more step. Yeah, it is more, right? Because of it is more already decided, why you go further. Again, check next string also. Is it more than 1073? One more, 1074 you do. Because of more, right? Stop it, go further. So I think there is no chance of hanging. There is no chance of hanging. Every one you can stop at 1074. Every string, it's a really nice problem. It is decidable. This is the last year GATE problem. This is the last year GATE problem. Very tricky problem, very easy problem. Very tricky and very easy also. After 1074, why I will go further? Because I got to know more than 1073. What a beautiful problem here. Really it's maja hai. Really nice problem. So the answer for this one is, which one of the following is undecidable? Answer is 1, 2, 3 undecidable. 1, 2, 3 undecidable. Yeah. Which of the following are undecidable? Can you see this also? Can you see this also? Yeah, check this also again. Which of the following languages are undecidable? Note that M indicates encoding of the Turing machine M1. Right, Turing machine will accept empty language, undecidable. Input W reaches state Q in exactly 100 steps. Right, on input W, right, machine M on input W reaches state Q in exactly 100. See, after 100 step verify, it is a decidable. It is a decidable. Right, L3 is equal to M, where L of M is not recursive. L of M is not recursive. Maybe, may not. Maybe, may not. Undecidable. L of M contain at least 21 members. At least 21 members. At least 21 members. You have to check one by one. You have to check one by one. You have to check at least at means who are those 21 members? You have to check. It's undecidable. So what is asking, which one of the following are undecidable? Undecidable. So if you observe clearly, I think 1, 3, 4. 1, 3, 4. 1, 3, 4. Yeah, exactly. Exactly. Other than B, he is asking which one of the following is undecidable. A. A. Emptiness. He said exactly 100 steps. Automata, right? Sorry, Turing machine reaches state Q. You can easily check. M is not recursive. Who knows? Right? L of M contain at least 21 members. How I know? I have to ask one by one, one by one, one by one. Right? One by one I have to ask. So answer is L1 undecidable, L2 no, L3 undecidable, L4 also undecidable. Right? Please careful. I think here I am stopping. So nice problems done today. Today we done the really nice problems. I hope these all will be useful to you. These all will be useful to you. Please let me know if anyone having any doubt before going to proceed further. Those people who want to join Unacademy, they can join. If you want to join Unacademy, you can join. Right? So one offer is going on 20% off. One offer is going on 20% off. Use this referral code. You can join. Whether this code you will apply or some other code you will apply, you can do whatever you want, right? So if you want discount, apply this, or some other better code is there, you apply. But my suggestion is, if you are serious, join as soon as possible. If you are serious, join as soon as possible, right? Price hike is there very soon. right? 30, right? 30 of this month price hike is there, please take care. 30 of this month price hike is there, please take care, right? Fine. So good night, see you in the next class.